velocity, it can be mass, it can be what? Uh, Pressure, whatever. If a physical quantity spreads through a particular region, right? If a physical quantity has spread to a particular region, we are calling that region as field of that particular physical quantity. Very carefully understand. Let's say, for an example, now that's a liquid. Now this liquid is flowing along this path like this. This liquid is flowing, right? The liquid is flowing along this path. Very carefully listen. When this liquid is flowing, we know that liquid is made with millions of liquid particles. If I want to analyze velocity of each particle flowing as a liquid, very careful understand. If I want to analyze velocity of each particle in the liquid which are flowing, then how do you represent the velocities? There are millions of particles. Then this particle's velocity is this direction. This particle's velocity is maybe this direction. This particle's velocity can be this direction. So likewise, when you consider entire this flowing fluid, you can say this entire flowing fluid region as a field of velocity. But you have to understand. Now, I want to explain what does it mean by field. Suppose if you want to analyze the velocity of each particle in a flowing fluid, then we can say this region through which liquid is flowing as a field of velocity. Suppose let's say if we want to analyze pressure at each point in the flowing fluid, if you want to analyze pressure at each point in the flowing fluid, then what can you say about this region? This region can be said as field of pressure. So then I think you understand what does it mean by field. Field means what? A region through which particular physical quantity has spread. It can be a pressure field. It can be a force field. It can be a what? Velocity field. The physical quantity that you want to analyze, the region through which that physical quantity has what? Spread, that is what we call as field of that physical quantity. But mainly we are into now. I mentioned that fields. We divide fields into two subsections. One is vector field, the one is scalar field. Now you know that what is vector field, what is scalar field, you can understand. Suppose the physical quantity that you are going to analyze is a scalar, the field produced by that scalar is we are calling as what? Scalar field. Suppose if you are analyzing the physical quantity is a vector, the field produced by that vector is we are calling as vector field. For an example, so field. So I can divide this into two subsections. One is scalar field, other one is vector field. Vector field. Now I have given some examples for scalar field. What we can say one of the scalar field as pressure field. I have given examples for vector field. Force is a vector. Then force is a vector. Field produced by the force we are calling as force field. Then velocity field is also vector field, right? Okay. Up to now everything is very clear. Raise your hands. How many of you understand? Up to now everything is very clear. Very careful, listen. Okay. So temperature field. Let's consider a body, an object or whatever. So if you want to analyze temperature at each point on this body, if you want to analyze the variation of temperature at each point on this object, we can say this region as a field of temperature. Then examples for scalar field, as I mentioned, I just explained temperature field and pressure field. Very careful listen. Temperature field, temperature field, pressure field, pressure field. Now likewise, vector field. So we can come up with plenty of examples for vector fields. One popular vector field is force field. One example for vector field is force field, right? One example is, popular example is force field. Now we can divide this force field into three subsections. One is gravitational field. One type of force field is gravitational field. That means gravitational force field. Gravitational force field. Other example is electric force field, electric field, if not electric force field. Other example is electric force field. The last one is magnetic force field, if not magnetic field. So usually we don't call all the times force field, but usually gravitational field, electric field, magnetic field, magnetic force field, magnetic force field, if not magnetic field. Now we want to understand what does it mean by a force field. Now force field means what? Force field means a region. It's a volume, it's a region. Region, through the region, if the force is distributed to the region. Suppose if we want to analyze the force acting at each point in this region, very careful listen. What is force field? If we want to analyze the force acting at each point in this region, then we can say this region is a force field. What does it mean by gravitational force field? Suppose forces are created because of masses in a region. We call that field as gravitational force field. What is electric force field? If forces are created because of what? Charges in a particular region, we are calling that as electric force field. Then what is magnetic field? In a region, poles are created because of what? Poles. Then we call that region as a what? Magnetic field. So then you can write down gravitational field means what? Region which can produce forces on masses. Region which produce forces on masses. On masses. We are calling as a gravitational field. What is gravitational field? Region which can produce forces on masses, that's what you call as gravitational field. Then what is electric field? Electric field means what? Region, it's an area, it's a region which can produce forces on charges. Positive charge, negative charge. Region which produce forces on charges. It can be what? Positive charges, negative charges, whatever the charges. Then what is magnetic field? region which produce forces on poles. Right. So how many of you understood what I explained up to now? Raise your hands. Everything is very clear. So raise your hands. Everything very clear. So what I want to say is one last time. Now you want to copy down this diagram. Before copying, look at it. Stop doing. Look at it. Look at it. Look at it. Now we want to understand what is field. I mentioned that field means in a region, if you want to analyze how a particular physical quantity is distributed. Very carefully listen. If you want to understand what is field, field means in a particular region, if you want to understand how a particular physical quantity is distributed throughout that region, we are calling that region is a field of that particular physical quantity. If you want to analyze the temperature on an object, then we can say that that entire object is a what? Field of temperature. So there is a temperature field. If you want to analyze pressure on a flowing fluid, we can say that flowing fluid, that region has a field of pressure. So likewise, what we can do, we can divide field into two subsections: vector field, scalar field. Suppose your physical quantity is a vector, the field produced by that physical quantity is a vector field. Suppose your physical quantity is a scalar, the field produced by the scalar is we are calling a scalar field. So I give some example. In this chapter, we are talking about force fields. Force field means one of the examples for vector field. We can divide force fields further into three subsections: gravitational field, electric field, magnetic field. Unit 5 is about gravitational field. Unit 6, that is about electric field. Unit 7 is about magnetic field. So coming consecutive three chapters related to force fields. So they are very careful to understand. Whatever the concepts that you learn in gravitational field, very similar to the concept that you learn in electric field. So therefore, don't miss this day. Until class finishes, keep your focus. Then you want to understand what is gravitational field. Gravitational field means what? It's a region. Gravitational field means a region which can produce forces on masses. We are calling that region as a gravitational field. So what is electric field? Electric field means what? It's a region which can produce forces on charges. Magnetic field means region which can produce force on poles. That's the idea. Up to now, everything is very clear. Raise your hands. Very clear. Raise your hands. Right. Now, what you do now, write on this note. If you finish writing, raise your hands. So keep raising your hands after you finish writing. And in case when you feel that my voice is not clear, then as soon as everyone leave a reply. So don't wait until someone replies. Now, when you hear that, if you can't hear me speaking, leave a reply. If you finish writing, raise your hands. Then there are two students finish writing. So I will give 2 more minutes. Then I will start explaining. Only one finished. Two finished. If you finish, raise your hands. Then I can start next part. Finished writing? So raise your hands. How many of you finished writing quickly? Don't take so much of time. Quickly write down these things. We don't have time. Done? Right, okay. Now put your topic. Gravitational field. Gravitational field. Write down. The region, write down. The region over which a force can be exerted on a mass. The region over which a force can be exerted on a mass is called as a gravitational field. Is called as a gravitational field. The region over which a force can be exerted on a mass is called a gravitational field. Next point, red color pen. Red color pen. Every mass has a gravitational field around itself. Every mass has a gravitational field around itself. I'll explain. Next point, that is also in red color pen. Force between masses. Force between masses. Force between masses are called as gravitational forces. Are called as gravitational forces. And gravitational forces are always attractive forces. And gravitational forces are always attractive forces. Right, okay. Highlight gravitational forces, attractive forces. Highlight gravitational forces, attractive forces. Now look at it. Now look at it. Now there is a gravitational field. Now I think you know what is a gravitational field. Let's consider this region. Now when I consider this region, we know that if I assume initially, this region is empty. This region is empty. Raise your hands. Now you have a region. I say that this region is empty. What do I mean by region is empty? There is no masses in this region. So very carefully understand. Suppose if we don't have any masses in a region, there is no gravitational field in that region. Very carefully understand. In a particular region that you consider, right? If there are no masses, then what we can say, there is no gravitational field. But suppose if I bring a mass to this region, right? Suppose if I bring a mass to this region, understand, let's say mass is simple limb, then what will happen? This entire region will become a gravitational field. What do I mean by gravitational field? Gravitational field means what? region which can produce forces on masses. Just initially this region was empty, and then there is no gravitational field. After I brought a mass, hereafter this entire region is a gravitational field. Suppose in a region it's a gravitational field, what will happen? When you bring masses, there will be forces on those masses. If this region is a gravitational field, what will happen? Now I say this region is a gravitational field. Gravitational field. If this region is a gravitational field, understand, when you bring masses into this region, there will be forces exerting on the masses that you bring. So basically, gravitational field means what? Region which can produce forces on masses. When you bring masses to this region, what happens? There will be forces. When you bring masses to this region, what happens? There will be forces. We are calling forces acting on the masses in a gravitational field as what? Gravitational forces. Gravitational forces. Right? For an example, let's say if there are two masses, let's say this mass is capital M, this mass is capital M. Let's say there is another mass, simple M, simple M. As these two masses are in the gravitational field, what happens? There will be forces acting on these masses. Obviously, capital M, on capital M also there will be a force. On simple M also there will be a force. So we call those forces as gravitational forces. Understand, when you consider two masses, forget about in the gravitational field, if there is only two masses, there are gravitational forces on each mass. Always the gravitational forces are attractive forces. Okay, attractive force. I will explain why this attractive later. After everything is very clear. After everything is very clear, raise your hands. Right. Okay. Now draw the diagram. Draw the diagram and mark down capital F. Capital F. Capital F is gravitational force. Capital F is gravitational force. If you finish writing, always raise your hands. Okay. Otherwise, I don't know whether you are writing or not. So therefore, if you finish writing, always raise your hands. Even I see you, even I don't see. Raise your hands. So right. Okay. Now write down. Important. Red color pen. To find out. To find out if there is a gravitational field. To find out if there's a gravitational field at a point. At a point. Comma. Comma. Check whether check whether there is a gravitational force. Check whether there is a gravitational force acting on a mass, acting on a mass placed at that point, placed at that point. Now look at it. Now this is also important. Now I mentioned that in a gravitational field, if you bring masses, what will happen? There will be gravitational forces on those masses. One last time, I explained in a gravitational field, if you bring masses, what would happen? There will be gravitational forces on the masses. Suppose there's a region, right? Now we want to check in this region, are there any gravitational field or not? Let's say you are considering a point, this point capital A in this field. Sorry. Now you have a region. Let's say point capital A is in this region. Now what you want to check is, you want to check whether this region is having a gravitational field or not. If you want to check this region is having a gravitational field or not, what you want to do? Now we know that if it is a gravitational field, when you bring masses, there will be gravitational forces. So if you want to check this is a gravitational field, what you do? Bring a mass to the point you are interested. Bring the mass in the region that you want to check. Suppose if there are gravitational forces acting on the mass, then what we can say? This region is a gravitational field. Do you understand? If you want to check a particular region is a gravitational field, bring a mass to that region, check are there any force exerting on that mass. If there are forces exerted on the mass, we can say that that region is a gravitational field. Right? Main topic. Main topic. Gravitational field intensity. Gravitational field intensity. So if you understand this point, then remaining is very easy. So this is somewhat, some people don't understand what is this gravitational field intensity. Try your maximum to understand gravitational field intensity. Inside the bracket notation is capital E. Some people use capital E as their notation for intensity, gravitational field intensity. If not, we can use capital E. On top of capital E, we are using an arrow, right? So therefore, mark down these two notations and write down like this. Write down like this. Right. Write down. A physical quantity is defined. A physical quantity is defined at any point in a gravitational field, at any point in the gravitational field to measure the strength of a field. To measure the strength of a field. Full stop. That physical quantity is gravitational field intensity. That physical quantity is gravitational field intensity. Red color pen, write down. Next point. Now the definition for intensity, okay? Write down like this. First of all, write down in blue color pen, then we'll write in red color pen. First of all, write in blue color pen. Gravitational field intensity at a point. Gravitational field intensity at a point in a gravitational field, in a gravitational field is defined as, red color pen, the gravitational force acting on 1 kilogram mass, acting on 1 kilogram mass placed at that point, placed at that point. Right. Now look at it. Now look at it. Now we know that, right? Now we know. Now, right. Now basically, gravitational field means it's a region which can produce forces on masses. Gravitational field means region which can produce forces on masses. Right? Now I say this is a gravitational field. You know that point to point, the force created by the field is different actually. For an example, let's say this gravitational field is produced by capital M mass, for an example, right? This gravitational field is produced by capital M mass. Now what happens? Everyone leave a reply. Now, what is gravitational field? Region which produce forces on mass, right? Then what can you say about the strength of a field? What do we mean by the strength of a gravitational field? If this region, at a particular point in the region, very careful understand. Now, what I want to understand is, now there's a gravitational field. It is produced by capital M mass. What do we mean by strength of a gravitational field? Suppose at a particular point in the field, if that particular point, if you bring a mass, if larger force is exerting, look at it now, I consider point capital E, I consider point capital B, I consider point capital C. I say point A is closer to point A is closer to capital M mass. I say point capital B is very far from capital M mass. Now, we want to understand what does it mean by a strength of a field. Now, I want to check gravitational field strength at point A, and I want to check gravitational field strength at point capital B. Now, how many of you say that? Raise your hands. How many of you say that gravitational field strength at point capital A is larger than capital B? How many of you say that a gravitational field strength at point capital A is larger than point capital B? Raise your hands. So you can understand, you have some sort of understanding. Now, when points are closer to the mass, there will be larger gravitational field strength. You have a sense, right? So when we go very far from the mass, gravitational field strength is decreasing. So everyone knows that. But I want to explain somewhat deeper. Now, what do we mean by gravitational field? Gravitational field means what? A region when you keep masses at any point in your region. When you keep masses at any point in the region, what happens? There will be gravitational force. Suppose at a particular point, let's say at a particular point, if the gravitational field strength is high, if your gravitational field strength is high, when you bring a mass to that point, what can you say about the gravitational force? What can you say when you now they have mentioned at a particular point, suppose gravitational field strength is high. When you bring a mass to that point, what can you say about the gravitational force on that mass? Very high. Suppose at a particular point, gravitational field gravitational field strength is low. Then what can you say about the force acting on a mass at that point? The force is low. Larger the gravitational force means larger the gravitational field strength. When your gravitational field strength becomes low means force acting on the mass at that point also low. Do you understand? So therefore we want to exact now. Anyone can say that when we go far from the mass, gravitational field strength decreases. That means gravitational force acting on the points when we go far from the mass decreases. But that is some sort of qualitative measurement of gravitational field strength. Now we want to define gravitational field strength. We want to find gravitational field strength quantitatively. You understand? For an example, let's say now I can say now there is student capital A, another student is capital B. Now let's say now if I want to come up with their heights, when someone replies capital A student is taller than capital B student, the measurement regarding height, that is a qualitative measurement. Student capital A is taller than capital B. But if I want to obtain a quantitative measurement, height of student capital A is let's say 1 meter, height of student capital B is 1.5 meter. Then this one is 0.5 meter taller than this one. That type of analyzation is what? Quantitative. Quantitative measurement of height. So therefore, likewise, we want to come up with some sort of quantitative measurement for gravitational field strength. That's why we are defining a new physical quantity called gravitational field intensity. Basically, gravitational field intensity measures what? Measures what? The force acting at that particular point in the field when you bring a mass to that point. Now I told you that why we introduce gravitational field intensity physical quantity to measure the strength at a point in the field. If there is a larger strength, there is a larger force acting on the mass at that point. If the gravitational strength is lower, at that point, force acting the mass at that point is lower. So basically, gravitational field intensity means what? Basically, it is defined as gravitational force acting on 1 kilogram mass at a particular point in the field. How many of you understand what I'm saying? Raise your hands. Understand? Understand? Raise your hands. Genuinely hands up. If you understand, raise your hands. Now look at it. Now, let's say how it is defined. This is very important. Look at it. Now, gravitational field intensity. We'll take a break. We'll take a break at what? Within 15 minutes, we'll take a break. Right? Gravitational field intensity. Gravitational field intensity. Okay? Capital E. Then it is defined as force acting on 1 kilogram mass. Force acting on 1 kilogram mass. Let's say now, if you want to find in this gravitational field, if you want to find intensity at point capital A, I say this point is point capital A. If you want to find the field intensity, how it is defined? When you keep 1 kilogram mass to that point capital A, very carefully understand. Now point A is in the gravitational field. We know that when we keep masses in the field, there will be forces. Gravitational field intensity means what? Suppose the point that you are interested, this time I am interested with point capital A. If you bring, suppose if you bring 1 kilogram mass to this point, if not, if you keep 1 kilogram mass at point capital A, If you keep 1 kilogram mass at point capital A, the force acting on point, the force acting on the mass 1 kilogram. Very careful understand. If you bring 1 kilogram mass to the point, the force, gravitational force acting on 1 kilogram mass, we are calling as intensity. So basically understand, gravitational field intensity means force per 1 kilogram mass. So understand, let's say there's a point capital B. Now they have mentioned exactly at this point capital B, intensity is given as E capital B. Everyone leave a reply. Intensity is E capital B. If not, intensity is capital E. Now they have given exactly at this point capital B, they have given intensity is capital E. My question from you is, when you bring, very carefully listen and reply, when you bring, now they have given intensity at this point capital B is capital E. Now you know what is intensity. Intensity means what? Force acting, when you bring intensity means what? When you bring 1 kilogram mass to this point, force is intensity, right? Suppose if I bring simple m kilogram mass, suppose if I bring simple m kilogram mass to point capital B, what is the gravitational force acting on simple m mass? Leave a reply. How many of you understand my question? At a point, they have given intensity. Intensity at a point is capital E. If we bring simple m mass to that point, I'm asking, what is the gravitational force acting on that mass? Leave a reply. Everyone leave a reply. Leave a reply, everyone. Let's check. At a point, they have given intensity as capital E, right? Now you know what is intensity. Intensity means what? Intensity means what? Force on 1 kilogram mass, right? At the point they have given intensity. Question is, when you bring, instead of bringing 1 kilogram mass, if you brought simple m kilogram mass to that point, what is the gravitational force acting on the mass? Leave a reply. I'm expecting some sort of, raise your hands. How many of you understand my question? Then I'm expecting replies from all. If you don't understand the logic, then you are not able to understand these coming chapters. Now, very easy. In the gravitational field, I explained what is intensity. Intensity means always understand, always in 1 kilogram mass. If you want to find an intensity at a particular point, when you bring 1 kilogram mass to that point, forces we are calling as intensity. Intensity means force acting per 1 kilogram mass. I'm asking, suppose when you bring simple m mass to that particular point, what is the intensity? Leave a reply. No reply. Me? If it is 1 kilogram mass, we know that. If it is 1 kilogram mass, when you bring 1 kilogram mass to this point, what is the force acting on the mass? Intensity. Then when you bring simple m kilogram mass to that point, what is the force acting on the mass? F equals me, right? So I hope you guys understand, right? That is what this is the idea of intensity, right? So now what you do, now draw this diagram. Look at it. Look at it. Okay. Now draw the diagram with me. Now in the gravitational field, right? Now in the field, draw this diagram with me, right? Now they have given they have given, let's say, at a particular point, they have given this point, intensity is given as capital E. Intensity is capital E, right? Intensity means when you bring 1 kilogram mass to this point, forces we are calling as intensity. Okay. Now, this point is point capital E. When you bring simple m kilogram mass to this point capital E, when you bring simple m kilogram mass to this point capital A, what is the force acting on simple m kilogram mass? If it is 1 kilogram mass at point A, force acting on the mass is we call as intensity. When you bring simple m kilogram mass, the force acting on simple m at point A is, I say, capital F. 1 over simple m equals intensity over capital F. When you substitute capital F, you will obtain what? Mass into intensity. Very important equation. How many of you understand up to here? Raise your hands. Understood. Raise your hands. Okay, quickly. Quickly. We'll write a sample question. Finished writing, raise your hands. If you finished writing, raise your hands. Right. Now, sample question. SQ. Gravitational field intensity at a point, write down. Gravitational field intensity at a point is 50 Newton per kilogram. 50 Newton per kilogram. Full stop. If 5 kilogram mass is brought, if 5 kilogram mass is brought to that point, comma, what is the gravitational force? What is the gravitational force acting on that mass? Acting on that mass. I will give 2 minutes. If you finish getting the answer, put the answer in the chat box quickly. I will give 2 minutes. If you finish doing this question, put the answer in the chat box. Quickly. Then we'll take a small break and come. If you finish if you finish getting the answers, put in the chat box. Quickly, how many of you got the answers? Finished? Right, okay, now they have given, look at it. Now they have given gravitational field intensity at a point is 50 Newton per kilogram. Now at a particular point, let's say intensity is given as how much? 50 Newtons per kilogram. Then what we want to find? Suppose if you bring 5 kilogram mass to this point, what is the gravitational force acting on the mass? We learned an equation F equals me. F equals me. Now they have given force, mass is 5 kilograms. Intensity at this point is how much? 50. Answer is 250 newtons. Okay. Now look at it. Now I forgot to mention the units of intensity. Look at it. Now we know from this equation F equals me, if I subject, look at it. If I subject intensity, I can obtain intensity as what? F over simple m. Force per unit mass. Intensity means force per unit mass. What is the unit of force? Newtons. Newtons. What is the unit of mass? Kilograms. Then what is the unit of intensity? Write down with me. Units of gravitational field intensity. Gravitational field intensity, newtons per kilogram. Gravitational field intensity, newtons per kilogram. Shall we find the dimensions of intensity? Dimensions of intensity. Dimensions of intensity. Intensity is capital E. Dimension means box bracket. Dimension of force over dimension of mass. Write with me. What is the dimension of force? MLT minus 2. MLT minus 2. MLT minus 2. Dimension of mass is capital M. Then dimension of intensity is LT minus 2. Then you are very familiar. LT minus 2 means dimension of acceleration. So somehow you will understand. Coming chapters you will understand. Gravitational field intensity means nothing but gravitational acceleration. Later you will understand gravitational field intensity means nothing but gravitational acceleration. Okay. Very important. Red color and write down. Intensity is a vector. It's a vector. Force ne samma. It's a vector. Okay. Right. Now we'll take a. How many of you need a break right now? Raise your hands. Need a break right now? Raise your hands. How many of you need a break right now? Raise your hands. Right. Now time is exactly 8:43. Come at 8:53. I will give 10 minutes. Come at 8:53 quickly.
If you can hear me speaking, leave a reply. Now I ask the question. Now currently there are 4 students. I'm asking if you can hear me speaking, leave a reply. Chat box. Others. Others. Everyone leave a reply. Only 2 replies. Only 2 replies. Right. Now put your topic. Newton's law of gravitation. Newton's law of gravitation. Now look at it. Now this is saying something like this. Newton's law of gravitation is very important law. Now we have learned Newton's first law, second law, third law in mechanics. Now Newton's law of gravitation. Now Newton told something like this. Newton told that when there are 2 masses, I see this mass is a capital M mass. I say there is another mass, simple limb mass. This mass is simple limb. Simple limb. Let's say the distance between capital limb and simple limb from their centers. Distance between capital limb and simple limb from their centers is simple r. Simple r. Now I mentioned that when there are masses, when masses in the gravitational field, there are gravitational forces on the masses. Right, and I told you that suppose if you have 2 masses, there will be gravitational forces on capital limb as well as simple limb masses. Here what happens, capital M produces a gravitational force on simple limb mass towards capital limb, because capital limb wants to attract towards capital limb. So then what is this capital limb? Gravitational force on simple limb mass by capital M mass, right? Every action has equal and opposite reaction. When capital M mass attracts simple M mass towards itself, simple M mass also produces a gravitational force on capital M mass towards simple M mass. Action reaction forces must be equal in magnitude, opposite in direction. They must be acting on 2 different objects in the same line of action. Understand, when there are 2 masses, there are always gravitational forces. They are attractive forces. Right? Newton told that magnitude of, when you consider two masses, you are entirely these two masses. The mass, its magnitude is directly proportional to multiplication of masses. Capital M, simple M, proportional to 1. Newton further mentioned that magnitude of attractive forces acting on each mass inversely proportional to distance between them squared, r squared. From proportionality 1 and 2, we can say what? We can say gravitational force directly proportional to capital M, simple M over r squared. We are removing this proportionality by using a constant. That constant is capital G, universal gravitational constant. Capital F equals capital G, capital M, simple M. So in an interval, if I tell you come before 8:53, you please come at 8:51, 8:50. You understand? Right after, as soon as time becomes 8:53, I start explaining. If you lately come, if you lately join, then I don't see that screen, right? Only I will watch. I will just go and see the screen. So therefore, make sure to come always before the before at least 2 minutes before the time that I give, right? So what I told is gravitational force between them directly proportional to multiplication of their masses, inversely proportional to distance squared. Then we can see gravitational force is proportional to capital M, simple M over r squared. Then F equals G capital M, simple M r squared. Very important equation. Very important equation. Now here, what is G? G means universal gravitational field, universal gravitational constant. Here capital G means what? Capital G means universal gravitational constant, right? Universal gravitational constant. Constant, right? From this equation, now I want to find the units of this constant G. If I subject G, I will obtain G as what? G equals F r squared over capital M, simple M. Then I want to find the what is the unit of F? Newtons. Unit of R, masses kilogram kg squared, kg squared. That will obtain Newton meter square kg minus 2, capital G. Units of G, right? This is also important. Then G value is G equals 6.67 10 to the power minus 11 Newton m squared kg minus 2. Now 6.67 means 20 over 3. 20 over 3. So when we do simplification, don't use 6.67. Write down 20 over 3. When you divide 20 by 3, 6.67 to the power minus 11 Newton m squared kg minus 2. Right. Yes. Write down quickly. Finish quickly. How many of you understand what I explained? Understood? Right. Okay. So if you finished writing, raise your hands. If you finished writing, raise your hands. Finished writing, raise your hands. Only one. Yes. Right. I will send the tute as a PDF. I will put in the group right now. So then we can do some tute questions as well. Right. Mm, wait a minute. I send the PDF of the tute. So go with that tute. Go with that tute. Start. Everyone start doing. I will give a few minutes. Everyone start trying question number uh, 1. First one. How so hands? How many of you start doing? That's a good question. I will start explaining. Just start doing by yourself. Then I will start explaining. So don't waste the time. Start doing. The gravitational force between two items kept in contact with each other is capital F. Between two other equal and uniform spheres made of the same material but having a radius half the radius of previous spheres when they placed in contact with each other. I will give a small guidance. Look at now tute question 1. Look at it. Now they are talking about uniform spheres. There are two uniform spheres, right? There are two uniform spheres in contact with each other. In contact with each other, right? Right. Okay. Now the spheres are identical. Let this sphere is capital R. I say, if not a simple B, let's say simple B. Then I will ask what is the number. Want to find the graph as distance measured from the center with each other. It's very simple B. What, leave a reply. What, leave a reply everyone quickly. When these two spheres are what, leave a reply. Everyone leave a reply. These two spheres are, you understand? Is it like only few only replying? Okay, right. Give me 1 minute. 1 minute. Right. Now tell me, still it's lagging? I think it's all right, right? Now it's all right. Leave a reply. Now is it okay? Right. I'm expecting replies from everyone. Be humble to reply. So if you can't reply for what we say, leave from the session. I don't mind. Right? If you can't reply, leave from the session. I don't mind. Okay? Because I didn't reply. So now what I'm asking is, suppose, let's say now these two are same identical spheres. Let's say radius of one sphere is simple b, radius of this sphere is also simple b. I'm asking, what is the distance between these two masses? Distance measured from their centers. Everyone leave a reply? Leave a reply. I'm expecting replies from everyone. Two simple b. Two simple b. Distance between these two masses, two simple b. Now then what happens? Now they have mentioned when two pairs of radius simple b, when they are in contact with each other, there are gravitational forces. Capital F, capital F, capital F, capital F. The question they are asking, suppose if now when the sphere radius is simple b, gravitational forces between them is capital F, capital F. Suppose if the radius of the sphere is half the radius of this sphere. Now radius of the sphere is how much? B over 2. Now radius of the sphere is how much? B over 2. When two identical spheres of half the radius of previous spheres. Now what is the gravitational force between them? I say gravitational force between them now is F dash, if not F1, F1, F1. Now the radius is B over 2. Now radius is B over 2. B over 2. And then what is the gap between these two centers? B over 2 plus B over 2. And then simple B is the gap. Now I want to find actually, what I want to find is the only given data is capital F. In question number 1, they have given only capital F. Then what we want to find? I want to find F1, gravitational force between these two small spheres in terms of capital F. My goal is finding F1 in terms of capital F. That's my goal actually. Now I can apply this equation, but the problem is I don't know masses. I don't know the mass of this large sphere. I don't know mass of this small sphere. So what can I say? Now they have mentioned all the spheres are made with same material. I say density of the material is rho, 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 rho. Right? It's a sphere. Now radius, I define the radius as simple b. I define density as rho. Right? Then I can find mass of these two spheres. Very careful to understand. I can find mass of these two spheres in terms of density and b. Why? If it is a sphere, what is the equation to find the volume of a sphere? 4 over 3 pi r cube, right? R cube. Now we learn an equation, mass over volume equals what? Density. Mass over volume equals density. So if you want to find the mass of a sphere, mass equals what? Volume into density. Our volume is how much? 4 over 3 pi r cube. Density is rho. So I can write down mass of these spheres in terms of radius and density. So if I apply this equation and if I try to find, I say mass of larger one is capital M, mass of small sphere is simple M, Then I can find mass of large sphere. Large sphere mass as what? If I erase this one, then I can find large sphere mass. Large sphere mass. How much? 4/3. 5. Radius of large sphere is simple b cube. Density is rho. Likewise, I can find the mass of small spheres. Small sphere mass. How much? 4/3 5 r. This time radius of our small sphere is how much? B/2. Then I can say b/2 whole cube means b/2 whole cube means b cube over 8. Density is rho. Now I can apply Newton's law of gravitation for large spheres and apply Newton's law of gravitation for small spheres. If I apply Newton's law of gravitation for large sphere, F equals G capital M simple M over R squared. For the large sphere, F capital F, G is a constant, mass of both the spheres are same. So capital M into capital M squared. I found mass of large sphere is how much? This one. Then capital M, both of them have same masses. G, capital M, simple M are same. Capital M squared. Capital M means this one, right? So therefore I can write down 4/3 5 b cube rho whole squared over distance between these two masses are defined as 2 simple b. This is my equation 1. How many of you understand up to here? Raise your hands. Understood up to here? Raise your hands. Right. Okay. Then likewise, I apply Newton's law of gravitation for small sphere as well. Small sphere, right? F dash, I want to find F dash. F dash equals G, mass of small sphere, G simple M squared. I found mass of small sphere is what? 4/3 5 b cube over 8 rho whole squared. Gap between them is simple b squared. I want to find capital F in terms of simple F, right? I want to find, capital F dash. I want to find capital F dash in terms of capital F. Okay. I want to find F dash, that means F1 in terms of capital F. Then what can I do? I can divide equation 2 by 1. If I divide equation 2 by 1, what will I obtain? If I divide equation 2 by 1, what will I obtain? If I divide 2 by 1, dividing equation 2 by 1, then I will obtain F dash means I think it's F1 over F1 over capital F equals what? Here GG cancel out. Here 2b whole squared, my bad, 2b whole squared. Look at it, then GG cancel out. Then G 4/3 5 b cube rho. Look at it. 4/3 5 b cube rho whole squared. Now I took this 1/8 outside. 1/8 whole squared. I can write down like that. Over 2b squared means what? 4b squared. 4b squared into this one. G 4/3 5 b cube rho whole squared. Sorry, I made a mistake. F1 over F means it must be b squared. It must be b squared. Then yes, then correct. 4b squared. Then you can understand This entire term get cancel out with this one. G cancel out. B squared cancel out. Now what is remaining? All remaining is F1 over capital F equals what? 1 over 8 squared into 4. 1 over 8 squared means 64 into 4 means how much? F1 equals 1 over 16 into capital F. That's the answer. How many of you understood what I explained? Raise your hands. Understood what I explained? How many of you understood what I explained right now? Raise your hands. Okay. Then what you do, right, quick copy down this one. Right. Copy down quickly. Finished writing this one, hands? Anyone finished writing this one? Raise your hands. Quickly. If you finished writing, raise your hands. If you finished writing, you must raise your hands. But I don't understand. I can't see. Still writing hands. Still writing, raise your hands. Right, okay, time is going. Subtopic, resultant gravitational field intensity at a point. Resultant gravitational field intensity at a point. Subtopic, resultant gravitational field intensity at a point. Write down. So you can take a screenshot if you could not write down because you don't have time. Write down. Topic is resultant gravitational field intensity at a point. Write like this. To find the resultant gravitational field intensity. To find the resultant gravitational field intensity at a point due to several masses
comma, first gravitational field intensity, first gravitational field intensity produced by each mass, produced by each mass is found, is found then their vector sum is taken, then their vector sum is taken, then their vector sum is taken. Now look at it. Now uh, right, okay, now look at this one. Now look at it, this one. Now we learned that gravitational field intensity means what? Force per 1 kilogram mass. Gravitational field intensity means nothing but force per 1 kilogram mass. Now look at it very carefully. Now previously we derived an equation for gravitational force, capital F equals mass into intensity, m into v, F equals mv. That was our first equation that we learned today. Now from that equation, if I ask you to derive equation for intensity, you will say intensity means force over mass, right? Force over mass. Now we know F equals me equation. We know that F equals me equation. If I subject intensity, we can write down intensity equals what? Intensity equals F over simple M. That's one equation, right? Now let's say I mentioned if your region is empty, there is no gravitational field. When you bring a mass to this region, what happens? There will be a gravitational field. So basically, gravitational field is produced by masses. Let's consider gravitational field is produced by capital M mass in this time. There is capital M mass, right? There is capital M mass. This capital M mass produces the gravitational field surrounding the mass. Around the mass, there will be a gravitational field. There will be a gravitational field. Now we know that when we go far from this capital M mass, gravitational field intensity decreasing, gravitational field strength decreasing, gravitational force decreasing. We know that idea, right? Now look at it. Now what happens? Now I want to find gravitational field intensity at a particular field, particular point in the field. I want to find gravitational field intensity at a particular point in the field. I am selecting this point. I want to find what is the gravitational field intensity at this point. I say this point is point capital A, point capital A, right? So let's say gravitational field intensity at point capital A. Look at it. Now what's my goal? I want to find the gravitational field intensity at point A. If you want to find gravitational field intensity at point capital A, what you want to do? Bring 1 kilogram mass to point A. Bring 1 kilogram mass to point A. When you bring 1 kilogram mass to point A, what will happen? There will be a force acting on 1 kilogram mass. That force is we are calling as gravitational field intensity. But this time look at it. There are two masses. Capital M produces the field. Simple M, that means 1 kilogram mass is in that field. What can you say about this capital M mass and 1 kilogram mass? According to this law of gravitation, there will be attraction forces, gravitational forces.
The gravitational force on 1 kilogram mass by this capital M. Okay, right? Gravitational force on this capital M mass by this 1 kilogram mass. Let's say distance between capital M and 1 kilogram mass is, let's say, simple r, right? Okay. Now we know that if I want to find the gravitational force on this 1 kilogram mass, what I want to do? I want to apply Newton's law of gravitation. Applying Newton's law of gravitation. Newton's law of gravitation. Law of gravitation. It says what? F equals what? G capital M into simple, this time my simple M is 1 kilogram. You want to apply Newton's law of gravitation? F equals G capital M simple M over R squared. Now you are F, right? Now please tell me, this F equals to what? Everyone leave a reply. Now I have marked gravitational force at point capital A on 1 kilogram mass. This capital F means what? Leave a reply, everyone. This capital F means what? Leave a reply. This capital F means what? Leave a reply. Gravitational field intensity. Because we know that gravitational force on 1 kilogram mass is we are calling as what? Always gravitational force on 1 kilogram mass at this point we are calling as gravitational field intensity. That means this capital F means what? Gravitational field intensity. This capital F means what? Gravitational field intensity. So therefore understand this capital F means what? Gravitational field intensity, capital E. Right? G capital M, this one is 1 kilogram, 1 R square. Then you can derive an equation for intensity at a particular point. Intensity equals what? G capital M over R square. Very important equation. Very important equation. How many of you understood intensity equation from capital M mass to a particular point, G capital M over R square? Raise your hands. Raise your hands. Then we learn two equations for intensity. One is F over M. Other one is intensity equals G capital M over R squared. This is also important equation. Right? Now in this time, look at it. Now look at it. I want to find the intensity at point capital B. Because this field is produced by this capital M mass. If I want to find the intensity at point capital B, what is the direction of intensity? Always intensity means when you bring 1 kilogram mass at point B, force. Always gravitational force towards this capital M mass. If you want to find the intensity at point capital A, look at the direction of force towards capital M mass. What is the direction of intensity towards capital M mass? If you want to find the intensity at point capital B, intensity means force, gravitational force. Intensity is always towards what? Capital M mass. So if you want to find the intensity at point capital B, if you know the distance to point capital B from the center of the mass, I say RB. Then you can say what? Intensity at point capital B means GM over RB square. What is the direction of intensity? Intensity vector. Direction of intensity is always towards the capital M mass. If you want to find intensity at this point,
Direction of intensity is towards capital M mass. Okay. After now everything is very clear, raise your hands. After everything is very clear, raise your hands. How many of you understand everything very clearly up to now? Raise your hands. Okay. Now write down these things. We are doing some questions, okay? I will stop at 10. Finished writing, raise your hands. Finished writing. Quickly. Quickly. Okay. Now look at it. Now, some theory parts. Now, what can you say about the variation of intensity around a mass? Still writing hands. Still writing, raise your hands. Okay. Now look at it. Now let's say now that's a mass, capital A is my mass. Okay, this is my mass, capital A. Capital A, right? Now I want to find the variation. I want to check how this intensity varies along this horizontal line passing to the center. When you go far away from this horizontal line, how this intensity varies. You got it? Now look at it. Now I will consider a few points. This point is point capital A, point capital B, point capital C, point capital D likewise. Here point capital D, point capital E, if you want point capital F as well. point capital F. Now, according to this equation, we know that, look at the intensity equals G means a constant into mass over R square. When you consider this particular capital M mass, if you want to find the intensity produced by this capital M mass field, capital M and G is constant. Then we can say intensity inversely proportional to what? 1 over R square. When distance from the mass increases to the point, what will happen? Intensity decreasing, right? When you go far away from this capital M mass, intensity is decreasing. What is the direction of intensity at point capital A? Always towards the horizontal line. Intensity direction at point capital A is towards the mass. And we know that comparing with point B and point C, intensity at point capital A is very high. Intensity, right? Arrow size represent the magnitude of intensity. What is the direction of intensity at point B? Same as towards capital M mass. But intensity at point capital B is what? Lower than intensity at point capital A. Therefore, I'm making my arrow small. EB. Intensity at point C is smallest. Smallest. EC. EC. Okay. How many of you understood I'm doing? Raise your hands. Understood. Then this time, point capital D, intensity always acting towards the mass. But point capital D is having larger intensity. ED. Then intensity at point capital E, somewhat smaller. E. Likewise, EF smallest. EF smallest. You understand? So what I want to tell you is, let's say the distance to point capital A from capital M mass is RA, RB, RC. RA, distance to point capital B from center of the mass is, I say, R capital B. Distance to point capital C from the center of capital M mass is, I say, RC. Then what can you say? When distance decreases, what will happen? Intensity increases. Intensity increases. My bad. When distance decreases, I will say like this, my bad. When distance increases, intensity decreases. Like this. Point D F also same the idea, but I consider only A, B, C, and I no, why don't this not? Make this not quickly. Finished writing? If you finish writing, raise your hands. Still writing, hands up. Still writing, hands up. Still writing, raise your hands. Only two. Okay. Right. Right. Okay. Right. Now again put the topic now. Resultant intensity at a point. Already I put and I gave a point, but I could not explain what is intensity properly. Now we can write down resultant intensity at a point. Now look at this very carefully. Right now, last 10 minutes you will stay with me. The last 10 minutes. Okay. Now look at it. Now, if you want to find intensity produced at a point by a mass, if you want to find the intensity produced by a mass at a particular point, we want to use G capital M over R squared, right? Now what happens? What will happen when there are many masses? Right now, let's say when there is only one mass, let's say mass is capital M, this one mass is capital M, then if you want to find the intensity produced by this mass at this particular point, capital A, I see this point is capital A. If you want to find the intensity at point capital A, we know if I know the magnitude of this mass capital M and if I know the distance to point capital A from the center of capital M mass, if I know them, what can I say? I can say intensity equals G capital M over R square. Intensity equals G capital M over R square. Right? What is the direction of intensity? Towards the mass capital M. That's normal thing. Suppose if you have many masses, let's say there are three masses, M1, there's another mass, M2, there's another mass, M3, another mass is M3. M3. At this time. Now, there are three masses. If I say distance to point capital A from M2 is, I say R2. Distance to point A from capital M1 is R1. Distance to point capital A from M3 mass is, I say R3. R3. Then the problem is, how do I find the intensity at point A? Now capital M1 mass also produces intensity at point A. Capital M2 mass also produces some amount of intensity at point A. Capital M3 mass is also producing intensity at point A. How do you find the resultant intensity at point capital A? What you want to do is separately find the intensities produced by each mass at the particular point. Separately find intensity produced by capital M1 at point A. Separately find intensities produced by M2 mass at point capital A. Separately find intensities produced by capital M3 mass at point A. Right? If you want to find the intensity produced by capital M1 mass, intensity produced by capital M1 mass, gravitational field intensity, gravitational field intensity produced by M1
at point A. What's that? I say it's intensity 1, E1, that is equals to G capital M1 over R1 square. Am I correct? Equation 1. If you want to find the intensity produced by capital M2 mass, gravitational field, not GF means not girlfriend, intensity produced by capital M2 at point A. I say it's E2. E2 equals G capital M2 over R2 square. If you want to find the intensity produced by capital M3 mass, produced by M3 at point A. What's that? E3 equals GM3 over R3 square. Directions E1 towards capital M. What is the intensity direction produced by M2 at point A? Towards M2. Towards M2. I say it's E2. Intensity produced by capital M3 at point A towards M3. I say it's E3. Then result, you want to take vector sum. So therefore, resultant intensity at A, resultant intensity at point capital A equals what? Vector sum, not algebraic sum, vector sum, because they are vectors. You want to consider the direction as well. E1, E2, E3. E1 value is what from 1? E1 means G. You want to do the vector sum, okay? How many of you understood what I'm saying? After everything is very clear, raise your hands. Raise your hands. Okay, quickly copy down this one. Now time is exactly 9:55. So when you copy down this, it will take 2-3 minutes. Then I will stop. Look at it. Now today we gave a small introduction for what this intensity. That's very important. So next day we are starting motion of masses around planets. Then within 2 weeks, within 2 days actually, because next day Wednesday and within 2 days we can cover unit 5 entirely. For in my theory class I completed unit 5 and I am started unit 3. So after completing this unit 5 we are going to unit 3. Unit 2 will be parallelly doing in Tuesday with 25 batch. So what you want to do is actually send your notes now after class finished, say, because I don't know if it's up to you, I don't mind about that. If you finish doing this session, send your notes as a PDF to me. Okay, we'll take a screenshot. Then today class is almost finished. Right now class is finished. Okay, I'll take a screenshot and I'll send you. Now you guys can leave. You guys can leave. I send the screenshot this in the group. Yes, leave. This Manilang also can leave quickly.